Okay, so this lesson deals with part 3 of the section dealing with fundamentals of probability. And in this case, we're going to be talking about empirical probability. In parts 1 and 2, we looked at theoretical probability. Now we're looking at empirical probability. Another word for empirical probability would be experimental probability. So experimental probability. So basically, empirical probability would be probabilities that you would get from experiments, and usually the experiments are surveys. All right, so many of the problems you'll see will be surveys or just an experiment that's being done. Okay. All right, so we're going to just go ahead and get started with some problems just so you'll see what the how to work empirical probabilities. It's the same way as theoretical. And so remember, a probability is a number between 0 and 1. We talked about that in part 1. And so so if E is an event, and this is the empirical probability, the probability of the event occurring would be the observed number of times E occurs. So hence the experiment divided by the total number of observed occurrences. So you can see what that means as we go through this. Okay. All right, so this would be number 1, and so this is in your packet in Canvas. So just make sure you take that out. I'm gonna try and enlarge this so you can see it a little bit better, though. So let's see. All right. Okay, so this number 1, we're gonna call this number 1. So number 1, you're told that Meds tested a new cholesterol medicine that was meant to lower levels of bad cholesterol. The medication was given to 500 individuals. So I'm assuming that if you add these up, you would get 500. With the following with the following results. So cholesterol lowered, there were 260. Cholesterol increased, there were 82. And the cholesterol stayed the same, that was 158. So this would be an experiment. So they did the experiment with 500 individuals. Okay? So that would be an empirical probability. So part A, why is this considered an empirical probability? Okay, so you could say something like, because the results are from experimental trials. Okay, so the results are from experimental trials. All right. Okay, so let's look at part B. Find the probability that the lowered cholesterol. Find the probability, that the drug lowered cholesterol levels. All right, so find the probability that the medicine lowered cholesterol levels. Well, first of all, we got to find out, well, how many of these 500 individuals did their cholesterol lower? Well, there were 260. So you would say 260 divided by 500. All right, so 260 divided by 500. And if you take your calculator and just write as a decimal, so let's see what that is. 260 divided by 500. And so that's about 0.52. So 0.52, or you can say 52%. But notice that that's the number between 0 and 1, isn't it? Okay. Find the probability that the drug increased cholesterol levels. So increased, there were 82. So you would say 82. So let's kind of look at the definition first. So that would be the number of times E occurred. So E in this case would be the event that the cholesterol level increased. So how many occurrences were there? 82, right? Divide by, and the total number of observed occurrences. So how many observed occurrences were there altogether? 500. All right, and then you put on your calculator. So 82 divided by 500, press equal, and you get 0.164 or 16.4%. Okay? Part D, find the probability that the cholesterol level stayed the same. So the event here was that the medicine did not improve or lower the increase or lower the cholesterol, that it stayed the same. So there's 158. So 158 divided by, and then there are a total of 500. And then when you use your calculator, that's going to be 158 divided by 500 you get 0.316, or you could say 31.6%. Okay? Notice that all these numbers are between 0 and 1. Part E, how could the approximation of probability be improved? So why would this be important in this situation? All right, so in other words, how could the approximation of these probabilities be improved? So remember, we only took a sample of 500 individuals, and there are probably a lot more that took this medicine, right? So there's probably a lot more. So this could be different based on how many were actually tested. So what you could say here, it could be improved by taking more trials. So this was just 500. So if you take more trials, you can improve these probabilities. These probabilities could get a little bit, what's the word? So they could get a little bit more exact, so to speak. All right, so it could be improved by taking more trials. Okay, so if more trials are done, the probability becomes a better predictor of results. Okay, so the more trials you do, the better predictor that these probabilities would become. All right, and then why would this be important in this situation? Well, probably because you remember we're dealing with medicine, we're dealing with people's lives. So in medicine, people's lives are at stake. Okay, so you need a lot of trials in order for these probabilities to be more predictable of what you're looking at. Okay, number 2, 6 friends chartered a fishing boat out of Port Arkansas to go bay fishing. By noon, they had caught 54 fish, as shown in the chart. So the 16 trout were caught, 14 redfish, and so on. Okay? All right. Part A. What is the probability that the next fish caught will be a redfish? All right. So there are 14 redfish, right? So they caught 14 out of 54. So this would be 14 divided by 54, which is going to equal, all right, so 14 divided by 54 equals, so let's go ahead and see how this is not terminated very well. So let's just go ahead and use the nearest 100. So it'll be about 0.26, 0.26 or 26%. Okay, so something like that, just go ahead and use the nearest hundredth and something like that. Okay, all right. Part B, is this an example of a theoretical or empirical probability? Explain your reasoning. So remember, this is an experiment, or so to speak. So you were just fishing, right? And you just recorded how many fish you caught and what kinds they were. So that is empirical. So empirical. So that's empirical. Experiment. So empirical, experimental sample of fish. So it was a sample of fish for that day to use as a predictor. Okay, so maybe the next day that would not be the same. All right, so that's why it's not theoretical. It's not always going to happen. So the probability of the fish being redfish is probably not going to be 26% the next day. It may be lower, a lot lower. So it's not a theoretical probability. This will not always occur. It depends on that particular sample that was taken. All right, 3. Let's make this 3. All right, hospital records indicate that maternity patients stayed in the hospital for the number of days shown in the distribution. So there were 15 maternity patients that stayed 3 days. That's what this is saying. There were 32 that stayed 4 days, 56 that stayed 5, and so on. All right, you want to find these probabilities. Find the probability a patient stayed exactly 5 days. So exactly 5 days. So how many stayed exactly 5 days? So 5 days, 56, right? So you'd say 56, but what else do I got to do? I got to find out how many patients there were in this frequency. So I got to add these up. So you're going to say 15 plus 32 plus 56 plus 19 plus 5. And so that's 127. All right, so 56 divided by 127 equal, and let's see, 56 divided by 127. So you see, so let's just say 44%. Always round to the nearest hundredth or the nearest thousandth. So about 44%. So that's about 0.44 or 44%. Okay. All right. Part B, a patient stayed less than 6 days. Now remember, less than 6 does not mean 6. It means 5. Remember, this means 5, 4, 3, and it didn't go down to 2. So we'll just stay at 3. So the answer will be so basically what you have to do. I'm gonna go ahead and put that here. So what you got to do for B is you got to find the probability of 3 plus 5, 4 plus 5 days. So that's going to be 15 plus 32 plus 56, all divided by how many were there altogether? 127, right? So 15 plus 32 plus 56 gives us 103 divided by 127, and that's going to be approximately equal to about 81%, 0.81, or 81%. Okay? All right. All right. Let me make sure. Okay. All right. So now let's look at part C. A patient stayed at most 4 days. All right. So remember, at most means this. At most means this. 3 or 4. That's what at most means. So at most means 3 or 4. And I don't say 1, 2, 3, or 4 because there's no 1 or 2 here. It only starts at 3. So at most 3 or 4 days. So the answer will be, so you got to add up how many stayed 3 days, how many stayed 4 days. So 3 and 4. So you're going to say 15 plus 32. So that's 3 is 15 days. I'm sorry. 3 is 14 people. 4 is 32. Divided by a total of 127. And that's going to give you 15 plus 32. 47 divided by 127, which is approximately equal to, about 37%, 0.37, or 37%. Okay. Part D, a patient stayed at least 5 days. So basically in this, you got to know what exactly means. You got to know what less than means. You got to know what at most means. And you have to know what at least means. So you've had that experience in previous courses and within your own life using those words. So at least 5 days means 5, in this case 5, 6, and 7. Okay, so at least means 5, 6, and 7. That's what the word at least means. Okay, so then we got to have 5 and 6 and 7, 5, 6, and 7, so 56. So the answer will be 56 plus 19 plus 5 divided by the total, which is 127. So that's going to equal, so 56 plus 19 plus 5, so that's 80 divided by 127, which is approximately equal to, and that's about what, 63%? So 0.63. Okay. All right, so that was number 5. Okay, and then number 4 rather. All right, so it says this. A group of high school students were surveyed about whether they own a cell phone or not. And so here's a survey. So you had 11 grade students and 12 grade students that were surveyed. And so basically what this means, make sure you know how to read this, there were 59 of those students, of 11 grade students that said they owned a cell phone, and then 6 of the 11 grade students that said no. And so notice that 65 is those two add together. So 65 represents the number of 11 grade students. 50 here represents the number of 12 grade students who own a cell phone. 3 is the number of 12 grade students that do not own a cell phone. Okay? And what do you think 53 means? 53 means it's these 3, so that's the number of 12 grade students that were surveyed. And then 109 would be of all those surveyed, and how many were surveyed? 118, right? This adds up to 118, and this adds up to 118. So 118 would be 59 plus 50 plus 6 plus 3. So all of the 11 grade and 12 grade students surveyed was 118. So 109 would be the number of students out of 118 surveyed that said they own a cell phone, so that includes 11th and 12th grade. And then the 9 would be 11th and 12th grade students that did not own a cell phone. All right, so that's how you read this table. Make sure you know how to read that kind of table. Okay, what is the probability that one of the students chosen at random owned a cell phone? Okay, well, how many students owned a cell phone? Many. Any student. It doesn't specify whether it's 11th grade. They're talking about any student chosen at random. Will be 109, because this plus this is 109, divided by 118. All right, which is approximately equal to, so 109 divided by 118. So about, they're probably going to ask you to round to the nearest tenth of a percent. Nearest tenth of a percent. So if they do, so you got to remember what we did in a previous lesson. So nearest tenth of a percent means you got to go all the way to the thousandths place. And so that's this right here. So since this is 5 or bigger, this becomes a 4. So this would be 0.924 or 92.4%. So what you got to do first is round to the nearest thousandth. Okay, round to the nearest thousandth. All right, and then now this is a tenth, hundredth, thousandth. So that's a thousandths place, and then you move it to you change it to a percent. Okay, did not own a cell phone. So how many of these students surveyed did not own a cell phone? Well, there were 9. So you'd say 9 divided by how many altogether? 118. And again to the nearest thousandth. So let's see. So 9 divided by 118. So it's about 0.076. 0.76. Which is about 7.6%. Okay, 7.6%. Okay, that the student was an 11th grade student. Okay, so that's all the window. What's the probability the student chosen at random is an 11th grade student? Well, how many 11th grade? Regardless of whether they have a cell phone or not, right? How many 11th grades are there? 65. So 65 divided by the total, which is 118, and let's see what we get there. So 65 divided by 118. So the nearest thousandth, that's 0.551, right? 0.551. Since that's 5 or bigger, that becomes a 1, which is, that should be R, which is 55.1%. And then finally was a 12th grade student who owned a cell phone. So here are 12th grade students. How many of them owned a cell phone? 50. Just 50. So it'll be 50 out of how many altogether? There were 118. And so to the nearest thousandth, that's going to become 0.424, right? Or 42.4%. Okay? All right, so that were 4 problems on the idea of empirical probability. It's not a very difficult concept. It's just using information that you have to answer questions. And so it's usually an experiment or a survey. So you notice in all these problems there was an experiment or a survey was done. So for example, this would be an experiment basically, and this right here would be a survey. So you survey students to see whether they own a cell phone or not. I mean, it could still be considered an experiment. You're doing an experiment by using a survey. Okay, so experiment or survey, but normally we'll say this is a survey we're doing. Okay, so you should be good enough to answer my math lab and the worksheet that deals with this.